Okay, this will probably be one of two parts for lesson 4. We're moving into something called identities, and I got you to watch last week a different teacher's video for lesson 4, and some of you wrote to me and just said that you had difficulty understanding it. So I wanted to make my own video for this lesson. Trig identities, you guys, it's a concept that is odd at first. But it's incredibly satisfying once you actually get the hang of it. It's sort of like the unit circle. The unit circle, it seemed really daunting at first, but then once everybody sort of got the unit circle and I said, okay, generate the unit circle, it's something that was no big deal at the end. And trig identities work the same way. They seem like they're going to be really difficult, but you'll actually enjoy it once you start understanding what it is. So the first thing, we need to understand what's the difference between an equation and an identity. So what an equation is, so we're used to equations. We've done this a lot. So 2x squared plus 3 is equal to 11. That's an equation. Now, this is an equation that's only true for certain values of x. And this equation only holds true when x is equal to plus or minus 2. So if I put in negative 2 or positive 2, I am going to get 11. If I choose any other values for x, I will not get 11. So it's an equation only for certain values of x, and that is when x is equal to plus or minus 2. What an identity is, an identity is when the left-hand side equals right-hand side, but it's true for any values of x, not just restricted to something like plus or minus 2. So for example, I'll show you what an identity would be. 3 open bracket 5 plus 2x. This is an identity, and it would be equal to 15 plus 10, sorry, 15 plus 6x. Let me fix that. 15 plus 6x. This would be considered an identity, and left-hand side would equal right-hand side. And I could pick any value for x, and I could plug it in on the left-hand side, and I would get that exact same value on the right-hand side. So whether x is 0, 1, 2, 3, 50, or negative 30, whatever value I choose on the left, it's going to equal to the right. So an identity is true for all values of the variable x, okay? We have actually done basic identities. So these are your basic identities. So remember that for this identity here, I told you to memorize that acronym 7 yellow rabbits. So 7 yellow rabbits. So sine is equal to y over r, cos is equal to x over r, tan is equal to y over x. Those are basic identities. Then we've done reciprocal identities, right? So cosecant is the reciprocal of 1 over sine, secant is the reciprocal of 1 over cos, and cotan is the reciprocal of 1 over tan. And basically, all I'm saying is I could pick any value for x over here, and I could plug it on the left-hand side and the right-hand side, and if they're equal, my identity is what we call true, okay? So let's look at this first example, which we're verifying identities for a particular case. So what they give us is tan x is equal to sine x over cos x. When we're doing these identities, we're always going to separate left-hand side from right-hand side. So normally I would draw a line here, but because they have this box, I'm going to put tan x over here, and then on the right-hand side, I'm going to write sine x over cos x. Okay, and what they want me to verify is they want me to verify x is 60 degrees. So they want me to verify left-hand side and right-hand side when x is 60 degrees. So you'd say, okay, the tan of 60 degrees on the left-hand side, sine of 60 degrees over cos of 60 degrees. If these two are equal, then what I've done is I've verified this identity. Now I could do this on my calculator, so I'll just quickly show you on the calculator, make sure you're in radian mode. So the tan of 60 degrees, actually it should be in degree mode. Okay, so not showing exact values. The tan of 60 is this guy here. And we're going to check, is that the same thing as the sine of 60 degrees divided by the cos of 60 degrees? And it is, right? So left-hand side equals right-hand side. We're verifying the identity. But what we want to do is we actually want to figure out, okay, well, where was 60 degrees on the unit circle? And use our correct radians. So for this, 60 degrees, so there's 30 and here's 60. Remember that 60 was 1 over 2, comma root 3 over 2. And if I said, well, what's the tan of 60 degrees? Tan of 60 degrees is y over x, right? So tan of 60 degrees is y over x. So that would be root 3 over 2. And instead of doing divide by 1 over 2, I'm going to multiply by the reciprocal. So I'm going to multiply it by 2 over 1. So the tan of 60 degrees is equal to root 3. Now, let's do this guy. The sine of 60 divided by the cos of 60. And we want to get, remember, root 3 as an answer. So sine of 60 degrees, that's your y value, right? So here's x, there's y. So root 3 over 2 divided by the cos of 60 degrees, which is 1/2, root 3 over 2 times the reciprocal, which is 2 over 1. That will cancel, and I get root 3. So my identity has been verified. I've got root 3 on the right and root 3 on the left. My identity is verified, or I've proven my identity. Let's do this guy here. So tan squared x plus 1 is equal to secant squared x for x is equal to pi over 6. So left-hand side, this is my dividing line. Left-hand side is tan squared x plus 1. And right-hand side is secant squared x. Okay, we're going to verify for pi over 6. Now, pi over 6, if I was to draw my unit circle, that, remember, is at 30 degrees. So 30 degrees is pi over 6. And that coordinate is root 3 over 2, 1/2. Okay, so tan squared x plus 1. So for this coordinate here, what's tan? So remember that tan is y divided by x. So tan is 1 over 2 times the reciprocal of this. Okay, this would be 1 over root 3. And then if I was to rationalize this, I'm going to multiply top and bottom by root 3. So the tan of 60 degrees is root 3 over 3, right? And if you have your unit circle, that first quadrant memorized, tan of 60 degrees should be root 3 over 3. So how I write that, tan squared x, well, tan of pi over 6 is root 3 over 3. So I'm going to write root 3 over 3. And then I'm going to square that guy, plus 1. Whenever you square a radical, it gets rid of that radical sign. So that would be 3 over 9 plus 1. 3 over 9 reduces to 1/3 plus 1. And now I need to get common denominators. So this is really over 1, but I'm going to put that guy over 3 and this guy over 3. So then I would get 4 over 3. So my left-hand side is 4 over 3. If I get 4 over 3 on the right-hand side, then my identity has been verified. So secant squared x. There's a couple different ways we could do this. So what they're asking for is the secant squared of pi over 6, right? That's essentially what they're saying. And that is that would be secant of pi over 6 squared, okay? Now, secant, the reciprocal of secant is cos. So on my coordinate, at pi over 6, I know that cos is root 3 over 2. So secant is the reciprocal of that, right? So secant would be 2 over root 3. So secant of pi over 6 is 2 over root 3 because it's the reciprocal of cos, and I'm going to square that. When I square this, 2 squared is 4. And when you square a radical, you get rid of the radical sign. So root 3 times root 3 is just 3. My identity is verified because left-hand side equals right-hand side. For class example 2, it says use the basic identities to prove that tan is equal to sine over cos. Okay, so how do we do that? What were the basic identities? So the basic identities were sine theta sine is 7 yellow rabbits, and cos theta is x over r, and tan theta is y over x. So those were my 3 basic identities. So again, normally I would draw my line here. So on the left-hand side, I have tan theta. And on the right-hand side, I have sine theta over cos theta. Using the basic identities, it's taking out tan theta and saying, well, what is tan theta equal to? Tan theta is equal to y over x, right? So that's using the basic identities. That's what tan theta is equal to. So y over x. So I get on the left-hand side, y over x. Let's see what happens when I take out sine and put in its basic identity divided by cos. What will I get on the right-hand side? If I get y over x, I've proven that identity. So sine theta, sine is 7 yellow rabbits. So sine is y over r divided by cos theta is x over r. Y over r times the reciprocal of this guy is r over x. And r cancel. Oops, sorry. R and r will cancel, and I get y over x. So I'm just going to write that down here, y over x. So as you could see, on the left-hand side, I got y over x. On the right-hand side, I got y over x. So now I could write left-hand side is equal to right-hand side. And then I'm going to end my identity just with a little box saying that like I've proven my identity that left-hand side equals right-hand side. What the next lesson will be on lesson 5, we're going to be doing restrictions, and there is a restriction in here, and I'll briefly talk about it now, but we'll really get into it in lesson 5. If I said, well, what would the restriction on sine over cos be? You would say, well, you could never divide by what? 0. So cos theta could never be equal to 0. That is my restriction. So when cos theta is equal to 0, this identity would be undefined. If I said, well, where is cos theta equal to 0? You'd say, okay, you'd quickly draw your Cartesian plane, and 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. They want to know where is cos equal to 0. So remember that cos is all of your x's. And this identity would be undefined whenever x is equal to 0, and that would be at pi over 2 and 3 pi over 2. So later on in lesson 5, we'll talk about cos can't be equal to 0, so this identity would be undefined at pi over 2 and 3 pi over 2, and how we'll write that will be in lesson 5. Okay, let's look at class example 3. So use the basic identities. So again, the basic identities would be sine. Now, sine of theta, 7 yellow rabbits. Cos of theta is x over r. Tan of theta is y over x. And then the last basic identity was, remember that on the unit circle. So if I go back to that first page with the basic identities, this guy here, x squared plus y squared is equal to r squared. So we're going to end up using that identity in this example. So I'm going to write that one down as well as a basic identity. So x squared plus y squared is equal to r squared. Okay, so let's prove this identity. So this is what I mean. I always like to draw a line, and I'm going to try to get left-hand side to equal right-hand side. Okay? Um, okay, so secant squared of a. So we know that secant is the reciprocal of cos, right? So my identity for cos is this guy here, x over r. And then if I said, well, what would the identity for secant be? If secant's the reciprocal of cos, the identity would be r over x. And then because it's squared, I need to square this guy. And that would equal to r squared over x squared. So I started with the right-hand side because it looked like this was going to be my easier side to deal with. And now what I essentially need to do is now that I've reduced the right-hand side to r squared over x squared, I'm going to look at the left-hand side and I'm going to see, am I somehow going to get this as an answer? Because if I can get left-hand side to equal right-hand side, I've proven my identity. Okay, so 1 plus tan squared of a. So, and remember, this is just, that's essentially theta, right? They're just using the letter A instead of theta. So this would be 1 plus tan, the identity for tan is y over x, right? That's the identity for tan. And they want us to square this. Okay, so what would we get? 1 plus y over x squared. So that would be 1 over 1 plus y squared over x squared. A lot of fractions we're going to be dealing with when we deal with identities, so you have to be very comfortable with fractions. Normally I would give you a question like this on your next quiz and I'd say it's a no calculator quiz. So if I said we'll get common denominators here, if I've got an x squared on the right hand side, I'm going to put an x squared over here. And then what I would have is my denominator is x squared, and my numerator, I would just add my numerators, x squared plus y squared. So you look and you say, okay, I've got my denominators being the same, x squared and x squared, but my numerators are different. Well, what you need to look for here is you need to just realize, oh, this guy is an identity. X squared plus y squared, I could take that out, and what does x squared plus y squared equal? It equals r squared. So you need to sort of be able to see that x squared plus y squared is equal to r squared over x squared. And then I have left-hand side is equal to right-hand side. And I verified or I've proven my identity. Okay, these identities here, super important and on your formula sheet. So your formula sheet, you're going to get overwhelmed at first because it's full of identities. But what you're going to realize is certain identities you'll just memorize, like these are quotient identities. So for example, you know from the basic identity that tan theta is equal to y over x, right? That's a basic identity. And that's just memorized. And then you know that that y is sine and x is cos. So the quotient identity, tan is actually equal to sine over cos. You will probably never, after this lesson, use this identity here. You will use this identity instead for tan. You'll say tan is equal to sine over cos. If I said, well, what's the basic identity for cotan theta? Well, we know that cotan theta is the reciprocal of sine theta, right? So cotan theta is x over y. That's the basic identity. You're not going to use this basic identity past this lesson. You will use this quotient identity. Cotan theta, x is cos and sine is y. Then there's these three Pythagorean identities. So these are what's going to take the most use to just sort of being able to identify these identities. I would say that this one is the most common one. Sine squared theta plus cos squared theta is equal to 1. But what you have to realize with all of these Pythagorean identities is they could be rewritten. So for example, if I said, well, what does sine square theta equal to? Like, what would this identity by itself be? If I said just isolate sine squared theta, you would say, okay, well, sine squared x is equal to 1 minus cos squared x, right? You get rid of cos squared x from each side. So they will only give you this one identity on the formula sheet, but from that identity, I could get what sine squared x is equal to, and I could also get, well, what is cos squared x? So if I said, okay, you guys, rewrite this on the formula sheet, the pink formula sheet that I gave you in class, write down what the identity for cos squared theta would be. So isolate that guy. Cos squared x is equal to 1 minus sine squared x, right? You'd have to subtract sine squared x and subtract sine squared x. For this Pythagorean identity, that's what secant squared is equal to. Well, now tell me what tan squared is equal to. So from that identity, from this Pythagorean identity here, you could rewrite it and say tan squared x is equal to secant squared x minus 1. Same with this identity here. This is cosecant squared x. This is what cosecant squared x is equal to, 1 plus cotan squared theta, or cotan squared x. Well, I could say, well, what does cotan squared x equal to? So just isolate that. So the identity for cotan squared x is cosecant squared x minus 1. Okay, so these Pythagorean identities we're going to use in the next few class examples. So class example 4, 5, 6, and then what I'll do is I'll do a second part 2 for this, and I'll do some homework questions. Okay, class example 4. Express each as a single trig ratio. Use a graphing calculator to verify. So I'm not going to use the graphing calculator to verify, but they want this to be written as a single trig ratio. So basically what that means is we need to get our fractions. We need to add our, pretend that these are two separate fractions and add them together. So this is really over 1. And I've got cos squared theta over here and a 1 over here. So I need to get common denominators. What I'm going to multiply the right-hand side by is cos squared x, and what I do to the bottom, I do to the top. So cos squared x. Okay, now I've got cos squared x and cos squared x, so my denominator is now cos squared x. Cos squared x. And my numerator is sine squared x plus cos squared x. And you guys, just to sort of review, this goes back to Math 20-1 when we did the fractions. So just to sort of review something with fractions, if you have common denominators, so let's say 3 over 4 and 2 over 4, what the rule was your denominator stays as 4. So in this case, I had cos x and cos x. So my denominator is cos x. And then you just add or subtract your numerators. So 3 plus 2 would be 5 over 4, right? Sine squared theta plus cos squared theta is sine squared theta plus cos squared theta. So this is now what I have, sine squared theta plus cos squared theta over cos squared theta. This is an identity. So you're going to get good at this identity later on, the more practice you get. For now, you're going to have to look at your formula sheet and say, like, what was the identity for sine squared theta plus cos squared theta? Whenever you see this is like my favorite identity, because that guy, I take this out, and that is equal to 1. Right? So this is an identity that could come out, and I could replace it with 1. And that's 1 over cos squared x. So technically, I could leave my answer here if I want. However, this would be a reciprocal identity. And if it wants it as a single trig ratio, I mean, technically that is a single trig ratio, but what would be the reciprocal of cos? The reciprocal of cos is secant. So this would be the same as secant squared x. And that would be um, A written as a single trig ratio. Okay, let's look at B. Sine plus cotan times cos. Okay, so let's deal with this. So sine x plus cotan of x. What was cotan? Cotan is cos x over sine x, and this is times cos x. I could extend my division bar, right? Because uh, this is all over sine x. Now we've got the name of the game, you guys, is always to do common denominators, tons of fractions. So this is really over 1. But if I have a sine x here, I want a sine x over here. So I'm going to multiply sine x and sine x. Now my denominator is sine x. Now I have to deal with my numerators. So sine x times sine x is sine squared x plus cos x times cos x is cos squared x. And then there's my favorite identity. Sine squared x plus cos squared x is 1. That identity is 1 over sine x. And sine x is a reciprocal trig ratio. What's that a reciprocal trig ratio of? That is equal to cosecant x. And I've expressed that as one term. Okay, class example number 5. I would say that this guy here by far is the most challenging. However, you'll definitely see a question like this on your quiz, and it would be on the exam. So okay, so what it's saying is it's saying express this in terms of sine and cos, right? And it's easy to do, right? Because I could take out tan and I could put in the identity for tan. And we know that the identity for tan, so if I use the letter A, tan is y over x, but we're not going to use y over x anymore. We're going to say that sine A over cos A, right? Okay, so let's express 2 tan A, but we know that tan is sine over cos. So what does this become? That would be 2 times tan. The identity for tan is sine A over cos A. And that is all over 1 plus tan squared theta. So tan squared theta, I use the exact same identity up here. That would be the same thing. I could, if I square the right-hand side, I could square the left-hand side, right? I could square both sides. So tan squared A is the same thing as sine squared A all over cos squared A. Okay, my numerator is pretty much done. 2 times sine A is 2 sine A all over cos A all over. Now I need to get common denominators here. So this is over 1. If I've got cos squared A here, I want cos squared A here. So cos squared A, cos squared A. Now my denominator is the same. So my denominator is cos squared A. And what's my numerator? Cos squared A plus sine squared A. Do you see the Pythagorean identity? So you should be able to look at this and be like, ooh, I could see something that comes out and the number 1 goes in. And the identity was this guy here. That is equal to 1, right? So if I go back up to my formula sheet, this is a Pythagorean identity. Sine squared theta plus cos squared theta equals 1. Our example was sine squared A plus cos squared A, but that guy is equal to 1. So I'm going to go down here, and I'm going to rewrite this as 2 sine A over cos A all over this guy is 1 over cos squared A. Now I'm going to rewrite this, and I'm going to rewrite this as this fraction times the reciprocal of this guy, right? So instead of dividing two fractions, I'm going to multiply by the reciprocal. So that would be 2 sine A cos A times the reciprocal of this guy is cos squared A over 1. Okay, if you have a cos squared over cos A, that's like having an x squared over an x, and you'd get x as an answer, right? So if you have a cos squared theta over cos A, that is equal to cos of A. So I've got 2 sine of A times the cos of A. And you would be done. That's as far as we could go. The question was express this in terms of sine and cos and write in simplest form, and I've done that. Okay, last class examples, class example number 6. We do not need to do A. I'm not going to worry about that guy. Let's look at B. So sine squared theta plus sine squared theta over cotan squared theta. Factor the following trig expression. So if I was to do this guy, from the left-hand side and the right-hand side, I could take out a sine squared theta. I could factor that out. So that goes in front of my bracket, and the answer goes in my bracket. Sine squared theta divided by sine squared theta is equal to 1 plus, that would cancel, and I'd be left with cotan squared theta. Whenever you see something like this, 1 plus cotan squared theta, you need to go up to your formula sheet and you need to say to yourself, is this an identity, right? So if I was to go up to my formula sheet, 1 plus cotan squared theta, here it is. That is equal to cosecant squared theta, right? So I'm going to take out 1 plus cotan squared theta and I'm going to put in cosecant squared theta. So this identity here is cosecant squared theta times sine squared theta. Now, this is a reciprocal identity. So what is cosecant the reciprocal of? That's the reciprocal of 1 over sine squared theta sine squared theta. Okay, where are we going with this? Sine squared theta times 1 is sine squared theta all over, there's basically a 1 on the bottom denominator there, so all over sine squared theta. Sine squared theta divided by sine squared theta is equal to 1. And we would be done. For your homework, these are the questions that are the most relevant. So these are the questions that I want you to do. And then from here, let's see how much time this is. I'm going to save this video, and then I'm going to do a part 2 for this, and I'm actually going to podcast these questions here.